Welcome back to the All About Data channel. In this video, we are going to understand one of the most important topics in Snowflake, Snowflake Architecture. Before working with Snowflake in real projects, it is very important to understand how Snowflake is designed internally and how different components work together. Snowflake follows a modern cloud-native architecture, which is completely different from traditional data warehouse systems. This architecture is one of the key reasons why Snowflake is fast, scalable, and easy to manage. In the upcoming slides, we will break down Snowflake architecture into simple layers and clearly understand how data is stored, how queries are processed, and how Snowflake separates compute and storage to deliver high performance. Don't worry if you are new to this concept. I will explain everything step by step in a very simple way. So let's start by understanding the core layers of Snowflake architecture in the next slide.
Now let's understand the Snowflake three-layer architecture, which is the core foundation of how Snowflake works. Snowflake is built using three independent layers: the cloud services layer, the compute layer, and the storage layer. Each layer has a specific responsibility, and they work together seamlessly. At the top, we have the cloud services layer. This layer acts as the brain of Snowflake. It handles important activities like authentication and security, metadata management, query optimization, global services, and the SQL API. Whenever a user submits a SQL query, this layer coordinates everything behind the scenes. The middle layer is the compute layer. This layer consists of virtual warehouses, which are independent compute clusters. Different warehouses can be created for ETL workloads, BI reporting, or ad hoc queries. Each warehouse works independently and can scale up or down instantly, ensuring there is no performance impact between workloads. At the bottom, we have the storage layer. This is where the actual data is stored. Snowflake stores data in optimized, compressed, columnar format using micropartitions. The storage is immutable, automatically compressed, and fully managed by Snowflake. The key advantage of this architecture is the complete separation of compute, storage, and services. Because of this separation, Snowflake delivers high performance, unlimited scalability, and simple management. In the next slide, we'll take a deeper look at how the storage layer works in detail.
Now, let's take a deeper look at the Snowflake Storage layer, which is responsible for storing and managing all data inside Snowflake. At the foundation, Snowflake uses cloud provider storage as the underlying technology. Depending on the cloud, data is stored on Amazon S3, Microsoft Azure Blob Storage, or Google Cloud Storage. This ensures extremely high durability, close to 99.999999999%, along with persistent and scalable storage. On top of the cloud storage, Snowflake adds its own intelligent storage layer. Here, data is automatically organized into small units called micropartitions. These micropartitions store data in compressed columnar format, which helps reduce storage cost and improve query performance. Each micropartition is immutable and encrypted, and Snowflake maintains metadata about the data stored inside them. Using this metadata, Snowflake applies header pruning, meaning it reads only the required partitions during query execution and skips the rest. This makes queries faster without requiring indexes. From a logical perspective, Snowflake organizes data into databases, schemas, and tables, which is familiar to anyone with database experience. Snowflake also supports multiple data formats, such as CSV, JSON, Avro, ORC, Parquet, and XML, making it easy to work with structured and semi-structured data. In summary, the Snowflake storage layer combines cloud scalability with intelligent optimizations, providing secure, efficient, and high-performance data storage. In the next slide, we'll move on to understand how the compute layer, also known as virtual warehouses, processes queries on this data. Now let's understand the Snowflake query processing layer, also known as the compute layer. This layer is responsible for executing SQL queries in Snowflake. All query processing is done using virtual warehouses, which are independent compute clusters. Snowflake provides virtual warehouses in different t-shirt sizes, such as small, medium, and large. As the warehouse size increases, the compute power also increases, allowing queries to run faster. Each virtual warehouse has its own local cache, which helps improve performance for repeated queries. One important point is that these warehouses are completely independent of each other. This means you can run ETL jobs on one warehouse and BI queries on another without any performance impact. Virtual warehouses can be started, paused, resumed, or resized instantly. You only pay for compute when the warehouse is running, which helps control cost. Snowflake also allows you to create or remove warehouses on demand, making scaling very simple. Behind the scenes, all warehouses access the same storage layer, ensuring consistent and up-to-date data for everyone. In summary, the compute layer provides elastic scaling, workload isolation, and cost efficiency, which is a major advantage of Snowflake. In the next slide, we'll look at the cloud services layer, which coordinates security, metadata, and query optimization across Snowflake.
Now let's understand the cloud services layer, which is often called the brain of Snowflake. This layer coordinates and controls everything that happens inside Snowflake. Whenever a user submits a query, the request first comes to the cloud services layer. The authentication and security component verifies user identity, roles, and permissions, ensuring secure access. Next, the query optimizer analyzes the SQL query and creates the most efficient execution plan. The metadata manager plays a very important role here. It stores information about tables, columns, micro-partitions, statistics, and file locations without scanning actual data. The infrastructure manager then decides which virtual warehouse should execute the query and manages scaling behind the scenes. Once the plan is ready, the cloud services layer sends instructions to the compute layer, which processes the query using virtual warehouses, while data is fetched from the storage layer. After execution, the results are returned back to the user through this same layer. In simple terms, the cloud services layer acts as a central controller, handling security, optimization, metadata, and coordination between compute and storage. With this, we have completed the Snowflake architecture, including the storage layer, compute layer, and cloud services layer, and how they work together using Snowflake's unique three-layer design. In the upcoming videos, we'll move into hands-on Snowflake, starting with account setup, virtual warehouses, databases and schemas, data loading using Copy and Snowpipe, and real-world query optimization. If this video helped you understand Snowflake architecture clearly, don't forget to like, share, and subscribe to the All About Data channel for more Snowflake tutorials. Thank you for watching, and I'll see you in the next Snowflake video.